Problem 16. Because triangle ACD and ABD have equal perimeters, that means AB plus BD plus AD, that's the perimeter of triangle ABD, equals AD plus CD plus AC. Because they have AD on both sides, so we can cancel them out. And then we plug in the values of the length of the triangle ABC. We will get AB equals 4 plus BD equals AC equals 3 plus CD equals 5 subtract BD. And then we move BD to this side. We will get 2BD equals 8 subtract 4 equals 4. That means BD equals 2. Now we also need to identify that the value of the sides of triangle ABC satisfies that 3 square plus 4 square equals 5 square. That means this is triangle CAB is a right angle. Therefore, if we draw a line from D to AB that is perpendicular to AB and assume it crosses AB at E, we will get DE is parallel to CA. Therefore, DE divide AC equals BD divide BC. That means DE divide AC is 3 equals BD is 2 and BC is 5. Then we can get DE equals 6 over 5. Now we can calculate the area of ABD. It equals 1/2 multiply AB multiply DE, that equals 1/2 multiply 4 multiply 6 over 5, it equals 12 over 5. So the answer is D. Let's use G to represent the number of gold coins and T to represent the number of treasure chests. Because when 9 gold coins were put in each treasure chest, 2 treasure chests are empty. That means G divide 9 equals T subtract 2. And if 6 gold coins are put in each treasure chest, then 3 gold coins are left. That means G equals 6 multiply T plus 3. Now we can substitute G in this expression into the first equation, and that will give us 6T plus 3 divide 9 equals T subtract 2. And we multiply 9 on both sides. To simplify, we get 6T plus 3 equals 9T subtract 18. That means 3T equals 3 plus 18 equals 21. Then T equals 7. So that means there are 7 treasure chests. And if that's the case, we plug T into this expression to get G. We will get G equals 6 multiply 7 plus 3 equals 45. problem 18. In order to solve this problem, we need to connect BD. Therefore, the area of ABCD equals the area of triangle ABC subtract the area of triangle. It should be ABD here. Subtract the area of triangle BCD. And the key here is to identify the relationships between those sides. We already know that AB equals 12 and AD equals 13, CD equals 3, and BC equals 4, plus angle BCD is a right angle. That means the length of BD equals the square root of BC square plus DC square. And that's BC equals 4 plus DC equals 3. And that means BD equals 5. So now if BD equals 5 and AB equals 12, AD equals 13, then we need to identify that 5 square plus 12 square equals 13 square. That means angle ABD is also a right angle. Therefore, because ABD and BCD are both right triangles, we can calculate their area easily. Triangle ABD's area equals 1/2 AB multiply BD. That's 1/2 multiply 12 multiply 5 equals 30. And the area of triangle BCD equals 1/2 multiply DC multiply BC. That's 1/2 multiply 3 multiply 4. It equals 6. Therefore, ABCD's area equals 30. Subtract 6 equals 24. Problem 19. In order to identify how many power of n is a factor of this expression, we first do some simplification to this expression. So 98 factorial plus 99 factorial plus 100 factorial equals 98 factorial. Multiply parentheses 1 plus 99 plus 99 multiply 100. And that equals 98 factorial multiply 100 plus 9,900. And that's 98 factorial multiply 10,000. Now let's look at these two individually. From 1 to 98, let's first consider how many numbers have a factor of 5. So we use 98 divide 5. We get 19 with the remainder 3. That means there are 19 numbers that has 5 as a factor. We also need to consider how many numbers in 98 that has 25 which is 5 squared, as a factor, and that equals 3 with remainder 23. So that means we need to add another 3 for the power of 5. And then we consider how many power of 5 are in 10,000. 10,000 can be expressed as 2 to the power of 3 multiply 5 It can be expressed as 10 to the power of 4, and 10 to the power of 4 is 2 to the power of 4 multiply 5 to the power of 4. That means it has 5 power of 4, that's 4 here, and we sum them up, it will give us 26. Problem 20. To solve this problem, the key is to identify that because the single digit, when it has to be an odd number, it only have 5 odd digits choices. So we need to write that down first. That's 5 choices. And once we choose that, then we consider the choices for the first number, which is from 1 to 9, and it can't be the 5 single-digit numbers, so it has 8 choices. Once these 2 digits are chosen, then the next digit is from 0 to 9, which has 10 total choices. But we subtract the 2 choices we already made. That's another 8 choices. And then the next number is also we can choose from 0 to 9, and we subtract the 3 numbers we already chosen, and that's left with 7 choices. Then we multiply 5. That'll give us the total choices. That's for the single digit, and that's for it's an odd integer, and the total number will be 9999 subtract 1000 plus 1. So we simplify this. It's on the top, it's still 8 multiply 8 multiply 7 multiply 5. Below it's 9,000 total numbers, and we can divide 10 on top and on bottom. That will give us 4 here, and then we can divide another 4. That will give us 8 multiply 7 on top, and below it's 9 multiply 25, and that's 56 divide 225.